just to describe how the semester is going to work, this semester next, this will really be a monochrome semester. We're going to deal just with learning how to create the views, create our own furniture, set up the plans, all that kind of stuff. And then next semester, once we have that under our belt, move on to thinking about materials and colors and lighting and rendering and whatever animation possibilities have evolved by then. When I say have evolved, it's really a busy time in the architectural imaging field. And there might be tools and techniques available by February that we don't even know about yet. I mean, things are changing that fast. So it's pretty exciting. I saw somewhere, I don't know if it was Thoreau or Nietzsche or Einstein or somebody saying that to be literate in the modern world, you need to be prepared to learn and to unlearn and then to relearn. And I think especially with regards to technology and the arts, that's entirely true. You know, Revit's probably the, I don't know, 6th CAD program I've learned in the past 35 or 40 years, something like that, starting with ones that were way less capable and way less friendly than even AutoCAD, and then moving up to Revit, which is really pretty accomplished and good program to work with. But Revit 2 will be superseded someday, probably be by an AI that you just tell it what you want and it draws it. Consequently, in terms of learning and in terms of learning on your own, I want you to explore outside of class any number of resources, and I list them here, starting with Revit's online tutorials. And they're good and they're useful. If we go over to Help, the Help button, and drag down these essential skills videos, I highly recommend at least the first several: video, tour of the user interface, and then these first two, modeling and navigate. If you want to proceed farther down the list, go ahead. We'll be doing the course, not in exactly that order, but the more you sort of learn from different directions, the easier it is to pull it together and sort of assimilate your own understanding of how Revit is going to work for you. Yeah, there's different versions of Revit. Starting in 2007, they pretty much just released a new version every March or April, somewhere in there. And the important thing to know with that is that your 2024 version can read any of those previous files and convert them to the 2024 format. But because Revit is still under development and new features and capabilities are introduced with each release, requiring a new file format with each new version of the program. And if you've saved a file with your Revit 2024, it cannot be opened by somebody using the 2023 version, which is pretty much most of the seniors are still using because they got them last year and haven't updated. So if you're going into a joint project where you know somebody else has 2023 or 2022 and you have 2024, one or the other of you will have to download and install the version to match the other one. I would recommend always sort of moving up. I would recommend that the other person get the 2024 version. It's not always possible for firms that have to pay more for them. They're sometimes reluctant to do that. Sometimes once they've really internalized how, let's say, Revit 2022 works, they just don't want to have to learn anything new. They just want to stay with what they know. So deal with that. Well, here, let's just open this sample architectural project. If we go to Revit and open, and on this page, we have a choice between recent files. Models are buildings. Families are like AutoCAD blocks. They're components that get inserted into buildings. So let's just start with this architectural one, just to have something that we can all see in common. Who here has built a dollhouse or played with dollhouses? Okay, good. It feels kind of like that. We build the whole thing, and it feels like a dollhouse because it's small on the screen, but actually it's just a zoomed out view of something that's as big as the building itself is. Once you've created the model and put the windows in the wall, you don't have to come then draw that window in the wall. You just say to Revit, from this position, look that way. And Revit knows what those things are in 3 dimensions and then displays them in 2 dimensions for you. And that gets at another major difference between AutoCAD and Revit, which is, in AutoCAD, as you know, when we're drawing lines, they're just lines. There's no intelligence associated with them. They're just lines on a particular layer. With Revit, we hardly ever draw lines. We would just go right to the wall tool and start drawing walls that we just indicate 2 points, but it's got thickness, it's got height, it's got materials on both sides, it's got structure inside, like that. And what I like to do is just sort of work through some of the basic tools, the navigation, how we create things, And then once we sort of have those pieces together, we'll start a new drawing, build a little house, and put some furniture in it and render it and see how easy this is. We'll each have a rendered building by the time we're out of here today. So with lights and sunshine. It's faster than AutoCAD. Okay, so let's do this. Let's start a new drawing, a new model. And I don't want to start with this one called Imperial Multidiscipline. That comes prepackaged with duct and pipe joints and all kinds of stuff that will just get us confused. So I want to click over to Browse. And just like AutoCAD had templates, Revit comes with templates, which are like empty drawings preset for a good way to work. And I would just like to use the residential default template, which comes with some furniture, some people, toilet fixtures, some light fixtures, but no ducts and no pipes and no mechanical equipment. I'll say residential default, and that stands for Revit template, the RTE there. Okay. Okay, so now we've loaded that one. Then we say, okay, let's use that one. This is important. We want to create a new project based on this template, not a new template. So let's look briefly at the parts of the screen. You notice there's no command line here. There's nothing we type and have to watch. It all comes off the ribbon here. And each of these tools across the top, and we'll end up seeing them, all of them, have different things to do. So for the building itself, we're working through here, walls and stairs and floors and ceilings. If we were doing structural, we'd have trusses and beams and that kind of stuff. We won't. Steel, yeah, we don't do it. We just stay over here. In fact, later on, we can just turn off structural and steel and precast concrete and systems, because that's not our responsibility at all. There are two other main toolbars that I recommend are always up and running, which are the project browser, which is where we are taken to the plans, to the floor plans or the elevations, eventually sections and other views we create. And that's where we modify. You can't move things around on the second floor when you're looking at the first floor. So we move to a second floor plan to do that. And then properties works just the way that properties works in AutoCAD. Once you've selected something, and we'll get to that, then everything about it comes up here, some of which can be edited and some of which is just informational. So let's just see how this works. Here in our drawing area, we can have a number of different views of these views there, see them either one at a time or tiled next to each other. They don't ever overlap. There's never a sense of things being hidden underneath other things. So let's just go to wall, architecture wall. And when you do that, first thing you do is just start drawing a wall. You just click and click and click and click. Okay. Again, like AutoCAD, you hit escape a bunch of times. Let me point out when we pick that, it tells me what kind of a wall that is, where it is in space, how high it is, that kind of stuff. And if we pick the ones that had brick on one side and wood studs on the other, it would tell us that. Now let's put in a door. Architecture, door. Under properties, it lists the current door, maybe the one that was last inserted. So let's just put that in. Now let's put in like a regular 36 by 80 door. So instead of sliding closet, we'll click there, and then all the other doors that are already defined here come in. Let's do single race panel with skylights, 36 by 80. Flashy, because then we get a little preview of it down there. Then you can place that in any wall. And as you move your cursor from one side to the other, the door flips to the other side of the wall. And if you hit spacebar, it flips back and forth. I've been talking about 3D all this time. This whole time, when you think you've been doing it in plan, you've actually just been doing it in a plan view of a 3D model. So let's go to View, 3D View. An important concept here is that, with our dollhouse idea, imagine that there's just like a bunch of surveillance cameras in the dollhouse that are just looking in all different directions at the same time. So if something happens, you get it on 2 or 3 different cameras. Let's split the screen between our first floor plan view and our 3D view. And that's in View, Tile Views. Same View, Tile Views. And now a little bit of navigation. I want to move this over this way. Just pushing down on the mouse wheel and dragging will bring me like that. You have to click in the view and do it. Okay, multiple surveillance cameras is kind of a creepy idea, but if you take your door over here and just click it and drag it, then it moves in that view as well. Click, drag. So there was that. If we want to put in a window, architecture window, then select one. It can only do it in the view that's in, so I can put it in here. If I want to put a window in this view, I have to click in this view to make it the active view, and then I can place it there. And those can be moved around as you wish. Let's talk now about using the mouse to navigate in 3 dimensions. We have the panning, which, like in the 2D views, is mouse wheel drag back and forth anywhere you want, zooming with the mouse wheel. And then we have the same view cube that we had in AutoCAD, where we can move around to see different views. Or elevation views if you want. It's just the same deal. Let's get back to that 3D view for a second. These are kind of limited view. Oh, this one will let us just drag it around. It's still all vertical, but drag it like that. And then holding down the Shift key with the mouse wheel will let you rotate it freely in space. Notice that in a 3D view, we can do that Shift mouse wheel to rotate. In the floor plan view, we can't. It just drags it around. In plan views, the surveillance cameras are just always aiming straight down. Now we're going to get a little more technical. We're actually sort of getting at the magic of Revit, is how I like to think about it, which is, AutoCAD is just this empty space where you can do whatever you want. You can draw gear, you can draw a solar system, you control the units, you control colors of everything, you control the names of layers. So it's extremely flexible. People from all over the world can use it for whatever they want it to, but there's no way to separate the first floor from the second floor from the third floor. It's all kind of stacked there. You can't turn off the first floor unless you have a whole bunch of layers named first floor walls, first floor furniture, or first floor toilets, and second floor walls, second floor furniture. Revit takes care of all that. Revit was invented in the early 2000s by some architects in Massachusetts who realized that AutoCAD's all things to all people's approach simply did not work effectively for buildings. First of all, they decided this is a program to model buildings with. We don't care about molecular structures. We don't care about solar systems. We don't care about bicycles. We're doing buildings. So they sent researchers all over the world to look at buildings and decide what do they have in common that we need to build into our software so this can be used everywhere. And they came up with sort of the following ideas. First of all, there are elements called datums that organize the building in space. Almost every building in the world, because people walk on flat floors, has the idea of levels, which are infinite horizontal planes corresponding, if you want, to the first floor, second floor, third floor, but can also be used for established, let's say, the top of a parapet at the top of a building, or the bottom of the foundations, just any continuous horizontal plane. And these are truly flat. They don't bend with the curvature of the earth or anything like that. They're just flat planes. Those are really the most important organizational concept that Revit brings that AutoCAD just did not have. And then, so if those are our horizontal organizing factors, levels, then there are also the possibility of using grids for like a column grid or a grid for structural beams to keep things organized in plan. And then we can also have what are called reference planes, which can be vertical, horizontal, slope, whatever you need. And we'll address those as time goes on. And then there are, associated with each of the levels, first floor, second floor, we have a number of views showing the different types of information needed by the different trades who will be working on the building. The main first floor plan would show furniture layout. The first floor framing plan would show the wall dimensions and door and window locations for the carpenters. And the electrical plan would locate outlets and specify fixture requirements for the electricians. And then a ceiling plan for the first floor. A ceiling plan is really a section looking up, cut like at 7'6" and just looking straight up. Doesn't see what's underneath, just what's from there up, like from the top of the doors up. And then for the physical elements of the building, we have the idea of host elements and hosted elements. The host elements are the ones built on site when the building is going up. Basically the walls, the floors, the ceilings, the roofs, the foundations like that, and stairs and ramps. And then hosted elements or component elements are ones that are hosted by something else, like a window. I can't just place this window in space. This doesn't happen in buildings. A window has to be hosted by a wall. It's sort of like a parent-child relationship. And if I move the wall, then the door and the window that are hosted by it go along with them. They don't just, AutoCAD wouldn't do that. AutoCAD would just leave them behind. So doors and windows are hosted by walls. Furniture ends up being hosted by a level, which we can zoom out and see our levels here that come with this template. First floor, second floor, roof, just for this beginning one. Plumbing is usually hosted by a wall, like a sink would stick to a wall. Lighting fixtures are attached to ceilings. So everything small, everything that's like brought in on a truck to a site is hosted by some element that's already there. And then finally, we've got some things that we can draw in various views as needed, but that are not physically part of the building. And I'll deal with them later on, but I like to just think about physical components for now. So if we want to, let's put in a floor. Let's go to architectural. And this is pretty much our entire drawing set of things that we draw with. Lines, rectangles, polygons, circles, a couple of different arcs, a fillet, a spline, ellipse, floor. In the top plane of properties is the current floor type. And we'll start with this generic one. And the trick here is to be sure that your level, we can be drawing this on the first floor or on the second floor, on the third floor, wherever we want to put it, but we want to be putting it, making sure that it's on the first floor. We can actually get rid of all those other layers because we're not going to be using them as interior designers. Footings and foundations, we don't have to worry about. That's not our job. So we can either do a rectangle or we can pick the line tool and draw whatever shape we like to fit the circumstances at hand. And once there's a continuous perimeter there in magenta, whether it's a rectangle or something else, then we hit the green arrow and say, okay. And finish. That means click the green check mark. Sounds like I'm talking to kindergartners. Our template here contains some families, a desk, some beds, appliances, light fixtures, plumbing fixtures. These are all components. These are things that are brought into the building. To place a component in the model, we go to architecture, component, place a component. We can then pick the ones that are here already contained in this template. We don't want a light fixture. I'm just going to scroll down here to, let's just pick a queen size bed. You see here we have component elements. These are the parts of a project that are not built on site like walls, but brought in on a truck and installed, like cabinets and furniture. And that's all here with component. And we have two ways to do this. We can just go place a component that already exists, or we can make our own, which we're not doing for a couple of weeks. And then with modify place component being the active command, over in properties, we can click on this image and either use it or go select any other object we want to do. Just do arrange. When you're placing a component, architecture component, place component, when you have choices in a command, AutoCAD would come up with another little line saying, what do you want to do, radius, whatever. Revit brings up this light green option bar, which tells you what it needs to know to place this object. And we'll say first floor, this for placing a component. And I'll say, I'll check rotate after placement, just so I can put that in and then rotate it as well. So it looks as though these guys are hosted by this floor. They're actually hosted by the level, the first floor level. If I delete the floor, they can still stay there. In fact, I can just component, place component. I'll pick that bed again. I can place this out here in space. Some of the few things that would actually be hosted by a floor are like a floor register for the HVAC stuff. All the other furniture and all go just by the level, just to keep it cleaner. And so you can delete a floor and remake it without all them disappearing. Some things, as we've seen, are hosted by walls, like doors and windows. When we get into doing cabinetry, component, we'll pick a base cabinet, double door. That's just attached to the that's attached to this first floor level. Wall cabinets attached to the wall. Component. Click on this, scroll down to W for wall cabinet. Wall cabinet, upper cabinet, sorry, upper cabinet. And that's attaching to a wall. So if I move that wall, the cabinet goes with it, but the top cabinet goes with it, but the base cabinet doesn't. One important concept that Revit uses that AutoCAD does not is the idea of constraints, the understanding that elements are connected to each other in various ways. Let me draw what are called model lines, and I've got my regular tools here. Let's just do a line here, and a line there, and a line there, and a line there. When things are drawn end to end, they understand that they are constrained by each other. So if I move this guy, the ends of the others go with it. It's not a polyline. Revit doesn't have polylines in the sense of a connected single element. It has multiple elements that know that if we drew them touching at the corners, they need to stay touching at the corners. I guess that would be the way to think about that. In the same way that these two walls are, just the way these lines are constrained, these two walls are constrained, this one to this one, and since I clicked to the endpoints of the wall when I was drawing the floor goes as well. So they're all mutual, that's what you want to have happen there. If I don't want the floor to do that, I can go ahead and edit it and move it back to where it was, but as a rule, I do. Okay, one other thing I want to touch on is dimensions and annotations. And anything that we create using the annotation menu, dimensions or lines or text or all that kind of stuff, only shows up in the view where you created it. So I don't have to worry about a dimension or a room name showing up in a different drawing. So if I go to annotate aligned, and I'm going to click the center line of this wall and then the center line of that wall and drag it out. Well, as interior designers, we really don't care even if we know where the center lines of walls are. So we need to say, structural engineers do, that's all they use. For us, we want to make a change here to say, when I say that, use dimension tool, I want to measure from the face of a wall to the face of the next wall. I'm going to use aligned, and now I'm going to say, here this option bar comes up. Don't go to the wall center line, go to the faces of walls. And it'll stay that way until we change it. And then I can just go from there to there, and that's what I wanted. Now, as you would expect, if we select a wall, and we can use the arrow keys to move it if you want, the dimension will update, just like AutoCAD. But even better, let's say you knew that was supposed to be 12 feet 3. I can select the thing I need to move, click on the dimension, change it to 12 feet 3, and it moves down. So to continue the concept of constraints, here the walls are constrained not by other walls, but by dimensions. in Revit, all of the tools that sort of show where things are can be used to change where they are. Pretty much nothing is on there just as a graphic symbol. It's always a tool that can be used to affect the drawing. There's something else we can do with dimensions. Let's say we don't know just where these two walls are going to be. They might move up and down, but they're going to move up and down together, always being 12 feet apart, 12 feet 3 apart. So I can click this dimension and lock it. Just click it and lock it. So whichever one moves, the other one goes with it. And each takes all the elements that it was hosting with it. And then if you decide, no, I need to open that up, we can unlock it. There are a number of editing tools that work much like their AutoCAD counterparts, like for filleting and bringing through things to a point. Something you do all the time in an interior design project is to get walls to meet at a corner. And in our modify menu, we've got this one, which is like fillet with a radius of 0. But for Revit, it's trim, shortcut is TR. All these have a shortcut, and we can just pick like that. And it works for walls in exactly the same way. If you did want to fillet those with, let's say, a 1 foot radius or something, and this applies to walls as well, practice with lines. Well, that was unexpected. All I did was Control Z. Video driver error has occurred. Revit will exit. To continue working, restart Revit. I don't know if this is because Revit hasn't been updated here, but that's something that I will call to your attention. Autodesk Access is an app installed with Revit 2024 and is the way to access program updates as well as download new software. Basically, it's the update program for all the Autodesk programs that you have. And we can see if that has anything I need to catch up with. Video driver error. Okay, well, this is interesting. I know that I'm on Revit 2024.1, and it's showing me there's a Revit 24.1.1 update, addresses custom reported issues and product instabilities. Well, I would say that was a product instability, so I will go ahead and let me just update, see how long that takes. Well, that took about 8 minutes, and while we were waiting, the class agreed that being able to use Revit to prepare perspective views based upon an AutoCAD floor plan was the most needful thing for their presentations 2 days hence. So we'll switch gears from the lecture outline to quickly creating perspective views. Unrehearsed. Insert, and we just want to import an AutoCAD file. And I was doing on my desktop a 3 demo drawing. And a couple of things we want to look at here. Let's accept all the defaults, colors, all this kind of stuff, and just say open. There's a lot of extra stuff here. I'll just pay attention to this one. Let's imagine that this was like the building perimeter, the 12-inch walls, and that these inside were all the 6-inch ones. Go to architecture, wall. And I think what I'll do is just do all these as 6-inch walls and then change the outside ones to 12 inches. Place wall, basic wall. We've got a generic 6-inch wall, so that's easy. You find that? Click here and then scroll till you find it. And then this is important. When we're placing walls, we're going to be indicating 2 points, and we get to decide whether that represents the wall center line or the outside of the wall or the inside of the wall. And I'm going to say that the points we place are going to be the inside of the wall, and we're just going to let the wall outside whatever it happens to be. So we're going to be, sort of inside justified here. So as we're drawing this, let's set up a couple things. Let's make its height be 8'5". So here's a whole bunch of options that we have to deal with. We'll make all these walls 8 feet high. We will say that this is the finish face of the interior. since that's where you're measuring to. We can use chain, which will just let us keep on going around, and that should be fine. And then we can start drawing a line. And again, it's just like with AutoCAD, we're just snapping from one endpoint to the next. And I know you have a different geometry, but let me just show you what this is getting me here. I'm just going to quickly do this. Now, each of these, so I drew all these at 6 inches. Each of these that is going to be an exterior wall, I can select it and change it into a 12-inch wall. And because it's justified on the inside, the extra thickness will go to the outside, like that. So if I select all these guys, I can change my entire perimeter to generic 12-inch. And then I'll do my inside walls at 6-inch. Let's just say I'm doing this. Well, and then I got some doors to put in. And you'll have to do this, pick the sizes that you want. So that's a quick, obviously, super quick way of putting in your exteriors and then doing the interiors and then putting in whatever your openings are. And a window, you could be the same way. And we can pick whatever size they are. The point is, once we have some walls and then your doors and windows in, to create the 3D view, I'm going to be like here looking this way, or maybe here looking down that little hall. We go into View, 3D View, Camera, View, 3D View, Camera. Put the camera where you want it to be, and then indicate the direction that you want it to look. Voila, woohoo. Doing this guy took us into this 3D, EXO 3D view. Let me get back into plan. But 3D view, camera. Asks you to place a camera, click 1, and click 2 is the direction you want it to look. And I'll go here so I get all my windows in. And then you could screenshot this and paste it into Photoshop or something like that. Are they double hung windows over at Cherokee's? About how big? 4 feet high. Okay. So, this is just the window that popped up. We can select it, and then any window that's selected, you can go over to Properties and click and get a list of all the windows that are here in this template. And those are double hung, the ones that slide up. So let's make this the 30 by 46 one, which is 30 wide and 46 high, just to see if that's starting to look better. And since yours is actually larger than this, let's imagine that really is like 3.5 feet wide and 4 feet high. Is that fair to say? Okay, so pay attention to this. This is important. Any of these, when we see the sizes here of these double hung windows, these are all types of a family called window double hung, which is the geometry, which is say top and bottom sash that move up and down, a divided light and the frame and stuff. But we can stretch those to different proportions by making what's called a new type of this family. So if we have the 30 by 46, window double hung 30 by 46, we can edit its type to create a new size of double hung window. Without having to recreate the geometry, we just change 2 dimension numbers, and there it is ready to go. So let's see how this works. Edit type. So And we've got these guys. These are the sizes already defined of the double hung window. What I want to do is to duplicate this one, duplicate the geometry, give it a new name, which we're going to call 3.5 is 42 inches wide. And we said 4 feet high. Wait, they got to be higher than that. Let's call it 5 feet. Let's call it by. So 42 inches wide and 50 inches high. That's just its name that's going to show up on this list. Then we actually have to change its dimensions to be 3'6" wide and 5 feet high. Apply. Okay. And we see it gets bigger. Those are probably down nearer the floor than are shown here. So maybe the sill height is a foot instead of 3 feet. I don't know where those actually are. So I'm thinking about what would you like to get out of here to be able to generate this perspective and then color it. I think at this point we'll just use the screen capture tool. You know, you've got the snipping tool I've got here, or you can go over to Start, Accessories, Snipping tool, which is just a screen grabber. So there, we can save this as a JPEG then. I think that's the fastest way to do that. Revit has higher resolution ways to do that, but we'll get to that probably next semester. I haven't plotted a perspective by hand since 1983. Just how long is that? 40 years? I'm just not going there. I'm just vanishing points and grids. I saw the light. So to repeat, setting up a 3D view, get into plan view, so you can place your camera clearly. Okay, on your level 1 plan. Under 3D view, hit this little drop down and pick camera. Put a camera somewhere. And you can adjust that later, but it's easier just to sort of create a new view. Here's something. Keep your cameras like about a foot away from the nearest wall or door or anything, because you can put a camera in a wall and then you can't see anything.